Welcome back to Arxflix. Today, we're diving into a groundbreaking paper titled Contrastive Preference Learning, Learning from Human Feedback Without RL. This research tackles the challenge of aligning large language models with human preferences, a crucial task in AI development. Traditional methods rely on reinforcement learning from human feedback, RLHF, which involves two phases: learning a reward function from human preferences, and then optimizing that reward function using RL. However, this approach has limitations. First, RLHF assumes human preferences are distributed according to reward, but recent work suggests they follow the regret under the user's optimal policy. This means learning a reward function is based on a flawed assumption. Second, RLHF faces optimization challenges due to the high variance of policy gradients and the instability of approximate dynamic programming. These challenges often restrict RLHF to contextual bandit settings or low-dimensional state-based problems. This figure illustrates the difference between traditional RLHF and contrastive preference learning, corporal. While RLHF uses a two-phase approach, corporal directly learns a policy using a contrastive objective, eliminating the need for RL. Corporal leverages the regret-based model of human preferences, which directly provides information about the optimal policy. This eliminates the need for RL and allows corporal to scale to high-dimensional and sequential RLHF problems. Corporal combines the regret-based preference framework with the principle of maximum entropy, establishing a bijection between advantage functions and policies. This allows for a purely supervised learning objective, where the optimum is the optimal policy under the expert's reward. Corporal offers several advantages over traditional RLHF methods. 1. Scalability. Corporal scales as well as supervised learning, avoiding policy gradients and dynamic programming. 2. Off-policy. Corporal is fully off-policy, enabling the use of any offline suboptimal data source. 3. Generalizability. Corporal can be applied to arbitrary Markov decision processes, MDPs, allowing for learning from preference queries over sequential data. The paper demonstrates corporal's effectiveness on sequential decision-making problems with suboptimal and high-dimensional off-policy data. Corporal achieves comparable or even surpasses the performance of RL-based methods while being significantly faster and more parameter efficient. This figure shows the performance of Corporal compared to baselines on the drawer open task in MetaWorld. Corporal outperforms baselines, especially with denser preference data, highlighting its ability to learn from more informative negative examples. This figure shows the impact of increasing the number of comparisons per segment on Corporal's performance. Corporal benefits from more comparisons, demonstrating its ability to learn from richer contrastive signals. Corporal represents a significant advancement in RLHF, offering a simpler, more efficient, and scalable approach to aligning models with human preferences. Its ability to learn directly from regret-based preferences without RL opens up new possibilities for tackling complex RLHF problems in various domains. Thank you for joining me on this exploration of contrastive preference learning. If you found this video helpful, please like, subscribe, and share it with your fellow researchers. Stay tuned for more exciting research summaries on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.